Hey there, and welcome to my video, or the first in a series of videos, I'm sure, on limits and continuity in regards to functions in calculus. So let's go ahead and just get into it. Here, you're welcome to pause it and read it. These are a lot of the skills necessary to be successful when we're doing evaluating functions for their limits and whether or not they're going to be continuous here. So limits and continuity are going to be pretty important, but let's see how we're going to be evaluating them. Now, if you're following along with the notes that are provided with this video, then this is probably not the first thing that you see. I really don't have a copy of it in front of me, but I remember when I was reviewing it, this is the material that I wanted to make sure students take a look at first. So you have this graph here, and it's not a very big graph. I apologize. I can probably make it a little bit bigger for you to see, but I don't want to overlap the graph, the table there to, avoid it. I don't want to overlap anything there. But we want to see, first of all, we're going to be looking at the table with this piecewise function and evaluating, do these things exist? Do I have a left-hand limit, a right-hand limit, or a general limit, and then is the function continuous at that point? So taking a look at x equals 9. When you look at x equals 9, the left-hand limit and the right-hand limit do match, meaning that, well, no, I'm saying that incorrectly. I apologize. Find the function value if it exists for, the limit. So if we're looking at x of 9, we're looking at this point right here. And you can't see white on white, can you? Let's pick a brighter color. Here we're looking at this point right here. That's about 3.5. It may not be exact, but it's about 3.5. So the left-hand limit does go there, but because the right-hand limit doesn't exist, the function stops there. The right-hand limit does exist. That means the general limit doesn't exist, and so it's not continuous at that point. Moving on to when x is equal to 4, you can see that x is equal to 4. Well, that is this part right here. This is where I have my vertical asymptote when x is equal to 4. So there is no value that's going to be there. The left-hand limit doesn't exist because it doesn't reach to 4. It stops at the 3. And the right-hand limit would go up towards positive infinity. The left and right-hand limits don't match, so there is no general limit. Looking at x is equal to 3, when x is equal to 3, you can see that the output value will be a 9. And the left-hand limit will approach that value of 9, but the right-hand limit doesn't exist because we can't approach that value from the right-hand side of the function. So again, we see a general limit doesn't exist. So far we're not really having much luck in regards of identifying whether a limit exists and whether or not it's going to be continuous. But here at 0, we're going to see a change. Now, why is it going to be different? Well, looking at the left and right-hand limits, we can see that the left-hand limit and the right-hand limit will approach the same number. They will approach a 6. So the general limit does exist. It's at 6. And if I substitute 0 into the function, I exist there at 6. So since the general limit exists and the function can be evaluated for x of 0 to be 6, then we can say that the function is continuous at that point. Moving on to negative 3, we can see that, well, negative 3, when I evaluate it, I do have a value down here at negative 6. That's why we're substituting there. And the left-hand limit and the right-hand limit do kind of, well, here's the left-hand limit and here's the right-hand limit right here. And they're approaching where that hole is. So the limit does exist there. The limit at negative 3 would be 5. But the left-hand limit and the right-hand limit, they're not, or I'm sorry, the general limit and the evaluation of the function at that point, they don't match. So that's why we're saying it's not continuous. And finally, when I look at x equals negative 5, at x equals negative 5, we have another jump discontinuity, so that in and of itself should tell you that the function is not continuous. And we've evaluated it for these particular values. We don't even have a general limit in this case. So moving on to what the definition of a limit is, or what the definition of what continuity is, rather, these are the things that you need to be able to use in justifying whether something is continuous or not in a calculus environment, either in a calculus class or on an AP exam. First of all, you have to be able to say that the function is defined at that point, meaning that if I plug a number in, I will get a number out. It will be defined. Second, the general limit must exist. If the general limit does not exist, it cannot be continuous at that point. And finally, those two things, the general limit and the value, the defined value at that point must be the same. And that's how we define continuity in calculus. So I'm going to go ahead and pause the video here since we're already at about 6 minutes, and I'll pick it up with the next section of our notes in another part 2 video. So if you have any questions about how we define whether or not a function is going to be continuous or not, please let me know. Until next time, guys, thanks for watching and take care.